It was an honored second when the Andromeda cloud for the present transformed into the Andromeda Infinite framework. The James Webb Telescope has perceived 6 universes that exist a portion of a billion years after the tremendous blast. This is incredible when you really look at the night sky, making the rounds a pinpoint of light at the point when broaden. It gives you one of these photographs from the Webb Space Telescope. It was an honored moment as the Andromeda cloud changed into the Andromeda world. For a long time prior, our cognizance of the Andromeda world was confined to base discernments. In any case, with movements in advancement and the presentation of the James Webb Space Telescope, our perception has developed tremendously. Now things are going to change as the James Webb Space Telescope has recognized upsetting signs coming from the Andromeda universe. These signs have sent shock waves through the academic community, leaving stargazers both inspired and curious. But what exactly do these signs mean, and why are they causing such a commotion among space specialists? Join us as just 2 minutes earlier the James Webb Telescope shut down right after receiving upsetting signs from the Andromeda vast framework. Previously we could see far beyond our eyes into the universe. Cosmologists trusted the Milky Way for being the whole universe. This shortfall of information was fundamentally because of limited advancement for seeing different inestimable frameworks and individual stars at any rate. Everything changed when we found the Andromeda world. It filled in as our most critical sign that the universe extends far beyond the Milky Way. In the 17th century, Galileo Galilei's initiating work with telescopes revealed the Milky Way's undeniable nature. He saw that the Milky Way had different stars, testing the winning idea of its specific meaning. Everything changed in the 1920s when Edwin Hubble saw distant objects beyond the Milky Way using the Hubble telescope. Edwin saw that the universes of these bright things moving through it were different from the Milky Way. The Andromeda planet, also known as M31, was one of the frameworks, and it was at this location that we first saw it with a telescope. Around the 10th century, Persian cosmologist Abd Rahman al-Sufi made the first observation of technological advancements. In 20th century, space experts could see and distinguish the true nature of Andromeda, which is an Indies cloud with a massive galaxy of stars similar to our Milky Way. Since its discovery, our emphasis on Andromeda has evolved from ground-based observations using telescopes to space observatories like the Hubble and the James Webb Space Telescope. Our limitless neighbor is about 2.5 million light years from the Milky Way. Every advancement in development has elevated us above all previous periods, enabling us to comprehend the mysteries of the Andromeda universe. We now possess greater knowledge and understanding regarding its formation and structure, establishing Andromeda as a standard for evaluating the evolution of universes. This has revealed more insights into the larger workings of norms of the cosmos. According to scientists, in order to see our world and the Milky Way more clearly, we should pay particular attention to the interaction between Andromeda and the Milky Way, particularly because there is no question that the two frameworks will collide for billions of years after research and evaluations have advanced. The high-level sensors on the James Webb Telescope have detected extraordinary development within the Android community. The sign sent back to analysts shows results that contrast through from previous discernments, dazzling scientists generally. The James Webb Telescope recently received an upsetting sign from Andromeda that confounds scientists generally and raises questions about its cautious starting and potential implications. Cycles throughout the globe that could be connected to its really massive black hole or newly unreported happenings. Remarkably, one of the most recent finds suggests that the mass of Andromeda may be far larger than that of the Milky Way, which would change the way we interpret both infinite frameworks. Furthermore, the emergence of new stars and their complex patterns have been shown by the James Webb Telescope's comprehensive images and spectra of Andromeda. This new information is essential to understanding the evolution of galaxies and the circumstances around life. Apart from studying the gravitational effects on the stars within Andromeda, the telescope data also points to prolonged development in the dynamic gas center of Andromeda, which has ultimately affected its surrounding environment and is anticipated to influence its future evolution. Trained experts discover tidbits of information on the dispersion of perplexing dark matter across the enormous framework, which should improve our comprehension of its impact on the elements operating in the universe. One of the most prominent concerns in astronomy is how to separate out dark matter and its effects on the cosmos. The James Webb Telescope's late forward jumps have sparked a number of investigations as analysts look into the inside realities of Andromeda. As more details become available, we learn more about the framework of the past and future. What have we learned about the Andromeda world from these investigations? Andromeda has shown essential traits that set it apart from other universes dispersed around the cosmos. Its immense seas bags for consideration and recent evaluations indicate that it is fast, approximately 220,000 light-years. This number places it among the greatest galactic frameworks in the local group, making it far more significant than the Milky Way. Its massive extension increases its mass, which includes a typical trillion stars, surpassing our vast framework in star count research. The framework structure is also regarded as charming. Unlike a typical winding framework, these qualities demonstrate a dynamic cosmos formed by steady processes, creating its advancement amid its various components. Andromeda's growing center and thick center wrapped within rings of dust and gas are unquestionably fertile grounds for persistent star development. One of particular significance is its center, which is characterized by a twofold zenith release, indicating the existence of a super-enormous black hole that is comparable to, but not quite the same as, the Milky Ways. This provides a wealth of information on the characteristics and operations of these enormous matter-eating holes. Stars, planets, and globular gatherings are among the subliminal debris that surrounds the Andromeda universe. This amazing covering, which spans many light-years in expanse, narrates an engrossing, well-organized tale of the world's fascinating beginnings in history. In order to uncover the mysteries of Andromeda, the 460 globular gatherings that were tracked down there also provide insight into the early phases of star formation, providing a clear explanation of how star gatherings developed and the early new cosmos developed. In any case, one question remains: how can they depict dark matter's perplexing nature and the role it plays in the constituent parts of enormous frameworks? Stargazers are getting a little bit closer to realizing the immense significance of dark matter. Another indisputable aspect of Andromeda is its satellite universes, whose crown structure contains more than 20 smaller infinite frameworks, some of which are streaming and rejecting their gas and stars in this cycle. Nearby minimum astronomical frameworks are drawn in and destroyed by a larger astronomical framework. This illustrates the dynamic character of massive growth and explains how universes form and interact over a long period of time. What does this mean for the Andromeda framework going forward? The form and trajectory of its evolution are crucial to the formation of Andromeda because they allow cosmologists and others trying to understand the cosmos to speculate that it could encourage a transition from a twisting to a ring universe if Andromeda is indeed moving in this direction. It indicates that it has had numerous associations with other astronomical frameworks since its first encounter with the world. Ultimately, Andromeda's future depends on the unavoidable accident with the Milky Way, as these models show. Verification focuses on a collaboration that could brief other captivating mixes, perhaps from grandiose effects or close relationships with various universes. Because of the enormous distances between the universes, this infinite crash is undoubtedly not an immediate, quick impact. The effect is predicted to occur primarily in 4 billion years, and the result of such an effect is the formation of a new world from these two giant stellar entities. In any case, it is a part of incalculable advancement. Following the impact, the two endless frameworks would be drastically altered, revealing new associations and forms. The correspondence of their gases and dust would initiate new star creation cycles, resulting in a massive display above as the mixed objects. The cosmos has a long history of such events, so this sort of impact is not unusual. In any case, our immediate attention makes it an event that is necessary for us. Eventually, such an endless event will lead to the creation of a lone circular universe. Furthermore, the radiant display is made more difficult by the anticipated collision of the quite massive black holes at the core of the two universes, which implies a huge and puzzling aspect of immense progress. It is anticipated that the union will communicate the effects of the problem being submerged by the black hole, which will transmit widespread radiation. In any case, this association provides important information about the movement of vast frameworks and the influence of black holes on this development. It also raises an important question: what will happen to our nearby planetary group once this combination is formed off by a long shot to a total obliteration of the nearby planetary group? The heading and conditions of the nearby planetary group could be significantly altered, suggesting possible orbit shifts or even launch from the newly emerged vast framework to handle this instrument. This allows scientists to focus on the scale of similar events occurring and contextualize the potential fate of our own universe. It is important to understand that an accident between stars is an extraordinary event in space because of the vast intergalactic distances. In any case, the gravitational change could cause some stars, including our Sun, to veer out of their stable orbits, which could have a significant impact on Earth's climate. Perhaps one of the most important changes people could encounter is moving closer or farther away from the Sun, which could result in one or more warming or cooling influences. A colder temperature would start another ice age, while a hotter one may cause ice caps to melt and raise sea levels. In addition, the calculation of such a strategy could prevent radiation levels from reaching Earth, creating far more difficult circumstances. The call tomb effect, which will alter the everlasting picture, is destined to occur in the Milky Way and Andromeda galactic frameworks. Perhaps one of the most important moments in the universe's design will be this collision, which is predicted to happen in around 4 billion years as the two universes speed toward one another. Their shared gravitational pole will start a breathtaking dance of tremendous capabilities. In the early stages of the accident, a new merged massive framework will form as a result of the astronomical centers finally merging throughout this cycle, which is not a direct hit, but rather a continuous mixing process. A remarkable star creation will be triggered by communications between the galactic plans and the gravitational agitation. Impact will pack as a result of interstellar gas and dust illuminating. New star births. The merging universes will be illuminated by a spectacular display of brilliant fireworks featuring newborn stars.